Hello everyone, welcome back to our video class here at CSEC Math Tutor. We are looking at number theory and a very important lesson. Today we are looking at sequence and patterns. Now you will realize that sequence and patterns gets a whole question on the CXC paper. Nowadays it's at number 7. In the other years you will find it at number 8. And most students love this type of question and they're able to reason out and obtain a lot of marks from this question. Our objectives: to list famous sequences, number sequences, identify a common difference in arithmetic sequences, and to determine the nth term of a simple arithmetic sequence. So first we're going to start off by looking at what some popular number sequences are. And very quickly, going through this, some popular number sequences are the triangular numbers. You need to know these. Very important that you know these. Triangular numbers are formed by making a triangle. So you start with 1, and then add 2. So you notice you get a triangle there. And then the second number is 1 plus 2. 1 plus 2 gives you 3. So it's 1, then 1 plus 2 gives you 3. And then if you add another row, you notice that your next triangular number would be 3 plus 3 is 6. And then that would be 1 plus 2 plus 3. And then 1 plus 2 plus 3 plus 4, etc., etc. And those give you the triangular numbers. They're very important, and they will pop up on your exam from time to time. Square numbers, same thing. Just a square number is when you multiply a number by itself. Also, when you find the area of a square of 1 unit or no unit or 2 units, so 1 square, 2 square, 3 square, 4 square, 1 square is 1 times 1, 2 square is 2 times 2, which is 4, 3 square is 3 times 3, which is 9, etc. 4 square is 4 times 4, which is 16, and it goes on. So square numbers are very important, and these are used a lot on your in your pattern questions. So know these. Same thing for cubed numbers: 1 cube, 2 cube, 3 cube, etc. And 1 cube means 1 times 1 times 1, or you're looking at the volume of a cube with unit 1, in which case you get 1. 2 cube, which is 2 times 2 times 2, which gives you 8. 3 cube, which is 3 times 3 times 3, which is 27, etc., etc. Or the volume of a cube with side 3. Same idea here. The Fibonacci numbers, these are very important. And these are not just important for math, but these come up naturally. These occur naturally in nature. So from snail shells to sunflower patterns to beauty in anything that we think as human beings is pretty, is cute, is beautiful, it has something to do with the Fibonacci numbers and the golden ratio. Everything to do with this. So even if you don't like math and you don't plan to study number series for mathematics' sake, this one, the Fibonacci numbers, speaks to everybody because it's something that is naturally occurring. Beautiful sequence that's naturally occurring. How do we find the next term? The next term is found by adding the previous two terms. So for example, 0 plus 1 gives you 1. 1 plus 1 gives you 2. 2 plus 1 gives you 3. 3 plus 2 gives you 5. 5 plus 3 gives you 8. 8 plus 5 gives you 13, and so on. 13 plus 8 gives you 21. So you can see what's going on. You add the first two to get the next one, and you keep adding to get the next one. So 21 and 34, 21 and 13 will give you 34, and it goes on. So the Fibonacci numbers are very important. They came on an exam a few years ago in the form of a recursive series. It is recursive, but that's something you can look up. Exponential series. So we take a number and we raise it to a power. So in this case, we're talking 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, etc., etc., etc. And 2 to the 0 is 1, 2 to the 1 is 2. You could use other numbers, but 2 to the n is very important because it is used to model behavior in terms of cell division and bacterial growth, etc. So 1, then 2, then 4, it keeps doubling over time. Exponential series. You could use other numbers. So you could use 3 to the n, in which case you have 3 to the 1 to the 0, 3 to the 1, 3 to the 2. This will give you 1, 3, 9, etc. Keeps going on like that. You could use 4 to the n, which would be 4 to the 0, 4 to the 1, 4 to the 2, etc., etc. Continue. So 1, 4, 16. So these are very important sequences that you need to know before you get into that exam, because it makes your life a lot more easier when you touch that number 7 question. But for the part of the question that gives students problems is this part of the question, the finding of the nth term. How do we find the nth term? How do we find the pattern that describes the numbers to get those extra marks when we have to generalize? Now, I'm going to show you how to find the nth term. And to find the nth term, first we look at something called the common difference. And note, these are arithmetic sequences, so they will have a common difference. All right, so I'm talking lots of new material here. The common difference is that we need to look at each pair of terms, each consecutive pair of terms, and say, what is the difference between them? So what is the difference between 13 and 20? 20 take away 13 is 7. All right, now look at 20 and 27. 27 take away 20 is 7. Let's look at these again. 34 take away 27. 7 again. And as you continue here, you'll notice that the difference between them is 7. So what does the common difference have to do with the nth term? Nth term. And the nth term is used to find all the terms. So if, for example, you wanted to find the 100th term, then you would use the nth term to find it. Show you in a moment. So what does the common difference have to do with it? Since your common difference here is 7, then the first part of your nth term is 7n. To find the next number, it's not complete, because 7 times, here is our first term, here is our second term, here is our third term. 7 times 1 is not 7. So we need to, it's not 13 rather. So we need to go back and see what we need to do. The second stage is to go back 1 term. So once you find your common difference, you go back 1 term. So let's go back 1 term here, which means that we're going to minus 7. And 13 take away 7 gives us 6. So the second part of our nth term is plus 6. This is the nth term for this sequence. And let me test it and show you. So suppose we wanted to find the first term. Then all that we do is substitute 1 here. And 7 times 1 would be 7. And 7 plus 6, 13. The second term, substitute 2. 7 times 2 would be 14. 14 plus 6 gives us 20. And if we wanted to find the 20th term would be 7 times 20 plus 6. And this is 7 times 20 is 140 plus 6, which gives us 146. And so sometimes your question may ask you to do something like this, which is to use the nth term to generate some other term. So this is how we find it. Let's try it again. Now, first, we're looking at the common difference. So what is the common difference between 1 and 12? Well, 12 take away 1 is 11. What's the common difference between 12 and 23? Well, that's also 11. Here again, notice that's also 11. Here, it's 11 as well. And 56 minus 45 is 11. So our common difference here is 11, which tells us that for our nth term, the first part of it is 11n. Now, notice that we need to go back 1 term. So we are here at 1, we're going to go back 1 term. And we're going to say 1 minus 11. 1 minus 11 gives us negative 10. So the second part of our nth term is negative 10. So this here is the nth term of this sequence. So looking at the first term, 11 times 1 would give us 11, and then we minus 10, and we end up with 1. 11 times 2 would be 22. 22 take away 10 gives us 12, and so on. So this is the nth term of this sequence. And this is how we find it. We find the common difference first, and then we go back 1 term. So you need some more practice on this. All right. Now let's look at the 20th term for this. So the 20th term would be 11 times 20 minus 10. And 11 times 20 minus 10 gives us 0 here, 2 ones 2, 2 ones 2, 220, take away 10 gives us 210. So this would be for our nth term, finding the 20th term here, for this one and this one. Now we're going to look at this idea of finding the nth term. Like I said, we're going to do some more of it because this is where I find that students lack confidence when answering these number 7, number 8 pattern sequence questions. Here's a question from CXE. The other bits are cut off because don't need them right now. And so we are going to look at the nth term here. First, let's look at what's happening here. 4, 8, 12. This is the diagram number. Let me put it in contents. Diagram number. And so the questions normally say draw the next diagram in the sequence. So this is the diagram number. This is the number of triangles, number of dots. We don't really need it to answer the question. So let's look at the pattern here. So 4, 8, 12. That tells us immediately that our common difference, 8 take away 4 is 4, 12 take away 8 is 4. And so we have the numbers 4, 8, and 12. So the common difference here is 4. Common difference is 4. And we can write down 4n immediately. And we need to go back one term. So going back one term, we are going to subtract 4. And subtracting 4 gives us a 0, which means that this stays exactly as is. So here, it's simply going to be 4n. In other words, you could look at or saying it another way, you could look at your number here, since you see that the common difference is 4, and say 4 times 1 gives me 4, 4 times 2 gives me 8, 4 times 3 gives me 12, 4 times what gives me this? 4 times 4 gives me 16, 4 times 10 gives me 40. What number do I need to multiply by 4 to get 64? And 4 times my number n equal to 64, which means that n would be equal to 64 divided by 4, and that is 16. Well, 4 into 4 goes 1, 24, 4, 6 is 24, so that number here would be 16. All right, moving on. We need to fill out this column over here. Now, in filling out this column over here, notice again, the common difference is 4. So let me use another method, and then we go back to this. So since our common difference is 4, we know that we're going to have 4n. But this is, when you multiply this 4, let's write it down. 6, 10, 14. So our common difference is 4. So we know that we have 4n. But we need to go back one term. So let's go back one term. And going back one term means we're going to subtract 4. So 6 take away 4 gives us 2. And that gives us the second part of our nth term. So our nth term for this column is 4n plus 2. So whatever number this is, 4 times 4 plus 2, 4, 4, 16 plus 2, 18. 4 times 10 is 40. 40 plus 2 gives us 42. And here, 64 plus 2 gives us 66. So finding the nth term in your sequence is very, very, very important because it saves you a lot of time. All right, let's look at another one. Here we have a figure. Note, so this is your figure number. Here you have the area of the figure, and here you have a perimeter of the figure in centimeters. Now, let's fill out these. Notice first up that these are square numbers. And in square numbers, you know, 1 times 1, 2 times 2, 3 times 3. So this is 4 times 4, which is 16. 5 times 5, which is 25. And that's why it helps to know the basic sequences. Here we'd be going 15 times 15, which is 225. Now, what I know for certain is that a lot of students, when they have this 4, 5, 6, and so they go write 36 and not pay attention and notice that there's a gap in the question. All right, so importantly, spot the pattern, spot the sequence that's going on. And since this is n, then this is n square. So this one is pretty simple. Now this one also is pretty simple. Notice that we have 1, 2, 3, and 1, 2, 3 corresponds with the figure number over here, 1, 2, 3. So the question is being kind to us, helping us to find it out. Notice that there's a common 6 and there's a common -2. So here, because there's a 4, we know that we should have 4 times 6 minus 2. 4 6s are 24. 24 take away 2 gives us 22. All right. Here there's a 5. So we'd expect to have 5 times 6 minus 2. 5 6s are 30. 30 take away 2 gives us 28. Now this is a 15. So we know that we should have 15 times 6 minus 2. 15 times 6 here is 90. 90 take away 2 is 88. Now, to fill out our nth term, we are going to write whatever number that we have here, which is our n, and times 6, and of course, -2. So we can leave that there, or we can write it pretty as 6n minus 2. So this one is not difficult at all. Now let's use this formula here. Which figure has a perimeter of 118? So we need to use this formula to see which figure over here would have that perimeter. So we write 6n minus 2. So whatever number we put in should give us a perimeter of 118. And as you see, you have a very, very simple equation. So 6n would be equal to 118 plus 2, which gives you 6n is 120. And then n therefore is 120 divided by 6. 6 into 12 is 2. And a 0 here, so our n is 20. Now, I've seen students answering this question and they write out every single number from 1 to 20 to get the answer. Waste of time. You will find your answer, but you will use up a lot of exam time trying to get that. So very, very importantly, I cannot overstate it that you need to find the pattern. Find the pattern first and then use the pattern to answer the question. So here our n, the figure number would be 20. We would actually use the pattern to work it out. And it saves you a lot of time and it's much, much more efficient mentally. Here's another one. And here we have the figure number again. And we have something else that's going on here. 1 plus 2 plus 2, 2 plus 2 plus 4, 3 plus 2 plus 6. So notice that this number is this number. All right. So we're at 6. So 6 plus 2 plus, what's happening here? This number is being doubled. 1, 2, 2, 4, 3, 6. So this number is being doubled. So this number would be 12. And you could work that out and get your answer. 12 plus 6 is 18 plus 2. That's 20. Now we take a skip there and we move on. And we are down here. And then we have some other things missing out. Now we need to work on the pattern. So the pattern here for this one, what's happening is that the first thing is there. So let's write the first thing. The first thing is n. Notice that the plus 2 is always there. So we put in our plus 2. And notice that the next thing is that this number is being doubled. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. So this is 2n. So let's simplify this. 2n plus n gives us 3n plus 2. And that's our formula for this one. All right. Now let's go to the other one. 5, 8, 11. 5, 8, 11. Now what is our common difference? Our common difference is 8 take away 5 gives us 3. 11 takes away 8. Take away 8 gives us 3. So we know immediately that the first part of our formula is going to be 3n. Now, to find the other part of our formula, we need to go back one step. So let's go back 1 and subtract 3. And subtracting 5 take away 3 would end up with 2. So the first part would be 3n plus 2, and 3n plus 2 is the formula for here. But here we had it already, 3n plus 2. So use the numbers to find the nth term and then use the nth term to work out everything, because it's way easier that way. Do not waste your time trying to figure out what each number is individually. If you do that, it's going to waste your time. Spend your time and find the nth term, and once you find the nth term, you can use it to solve everything else. So here we have 6, and so this number here is simply going to be 3. Let me write it in this section. 3 times 6 plus 2. And 3 times 6 is 18. 18 plus 2 gives us 20. There we have it. So here we need to figure it out. What do we need to multiply by 3 and add 2 to get 65 in this one? So 3n, here we have a simple equation, so we just need to solve it. 3n is going to be 65, take away 2. So 3n is equal to 63, and dividing by n is equal to 63 divided by 3, which gives us 21. So this number here is 21, and so we could write it as 21 plus 2 plus double this, 42. And so this answers our question. Now we have another part of the question here. Show that no figure can have a perimeter of 100 units. Now 3n plus 2 describes our perimeter. Show that no figure can have a perimeter of 100. So can 3n plus 2 give us exactly 100? Where n is a whole number. Notice these are all whole numbers. So let's try it. 3n is equal to 100 minus 2, which is 98. And then now we need to divide. N is equal to 98 divided by 3. Well, 3 into 9 goes 3 times. 3 into 8 goes 2 times. Leaves 2, 3 to 6. And then we have 2/3. So notice here that we do not get a whole number here. And the numbers, the figure numbers, you'd have to have a whole number for the figure number. 32 and 2/3 is not a whole number. So we have answered the question. We cannot have a figure of perimeter 100 because there is no, this answer doesn't give us a whole number. Spend your time figuring out what the pattern is. And once you've figured out what the pattern is, use that information now to answer the rest of the questions. And I can guarantee you it's way, way easier doing it that way than to just write down and try to write out everything in order to answer the questions. Remember, you can find more practice material here. Look in the multiple choice section. You will need those for your practice for your multiple choice exam. Look in the paper 2, paper 3 section, and look among the past papers. Many, many, many questions there for you to practice. Remember, these questions pop up at number 8, or they pop up at number 7 in the new paper since 2018. Thank you for watching. Subscribe, share with somebody who's doing the exam. Keep working hard, and best wishes as you prepare for your exam.